Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I'm going to talk about how to model a trimaran ship hull mesh in ProteusDS for ship motion prediction. So the reason I thought this would be useful is that there aren't really a lot of trimaran specific hull modeling tools out there, and it can be kind of tricky to figure out the way to create a multi-hull mesh like this, a trimaran mesh like this, and then process it, get it ready for import into a hydrodynamics tool for seakeeping analysis. So what we're going to do is use the Orca3D plugin for Rhino. This is a great tool because it has so many awesome hull modification features for adjusting and tweaking the shape of the hull. And the first thing I'm going to do here is just double check the properties that I've got forward as positive X. That makes it easy to bring the output from Hull Assistance into ProteusDS. So ahead of time, I was working with Hull Assistant and kind of shaped things out for a sample trimaran. I'm going to show you now how to put it all together and get it into ProteusDS. So the short story is we do this in two steps in using Hull Assistant. We do the AMA, and then we do the main hull. And we put it all together in Rhino here, apply the quad remesh to it, and then bring it into the ProteusDS ShipMo3D toolset. So I found it a little easier to do the AMA first, so we'll do that. And if we open the assistant that I've got here, you know, I was generally aiming, this is not based on a real trimaran, I was generally aiming around a 30 meter length, roughly 10 meter beam, sort of roughly 100 ton displacement, you know, with a pretty shallow draft. Now, speaking of displacement, if we just preview the hull here, you have to be a little bit careful because when you're looking at the preview of the hydrostatics, it's only going to be the individual hull components, not the whole trimaran. So you have to kind of manage that sort of separately a little bit. So, but you can see here this AMA is sort of around 13 tons. And again, you know, the real advantage of Orca3D here for Hull Assistant is all the functions and features you have for adjusting the hull form factor to however you want. I've got a pretty basic shape here. And we'll go back to dimensions, set the draft to 0, and turn off the hydrostatics. And so what we want to do here is go create, and then we want the full model for the AMA. And then we're going to put it off to the side. So we'll select the whole thing, go move 0, 0, 0, and then point to move to 0, 5, 0. So that's going to give us sort of real roughly our 10 meter beam with that spacing. And then we'll go to Orca3D hull design again, and we'll do the main hull. So we'll go down to my trimaran here. So, this is my own naming convention here. I just put trimaran 30 meters, even though the AMA is not that long. I just wanted them to be part of this, remind me that they're part of the same 30 meter trimaran. So now we'll go to the main hull and go open assistant and preview the hull. You can see there's the main hull, only half of it there. And again, we'll just do a preview of the hydrostatics at 1 meter draft, sort of like 83. So 83 plus sort of 20 and a bit for both the AMAs would get us a bit over 100 tons. Okay, so we'll go back to 0 here for that. And then we don't want to do the whole thing for the main hull because remember, we only want to bring in half of the hull for the whole system, and it's mirrored about the midplane inside the ShipMo3D toolset. So what we'll do is we'll go create, and then we only want port, hull, deck, and transom. And there we go. So there's our two surfaces. Now these are surfaces, they're not a numerical mesh that we need for doing the hydrodynamics calculations in ProteusDS. So what we'll do is we'll select these separately and go quad remesh. This is going to generate our quad form from the surfaces. So we'll go preview, and it's going to do some calculations here. And it's good to check it over. Don't assume that everything is good. Every so often there might be like a piece missing or something like that. I leave the input surfaces on, and you can kind of see how they're sort of overlapping really tightly, and we'll go hide input objects. All is looking well. If something looks weird and like maybe the transom's not there, try just adjusting the target quad count and it'll recalculate and often just sort of fixes itself. So we'll delete input objects as well because we don't want to keep the surface. We'll go OK. So there's our mesh of the AMA, which is great. And then we need to do the same for the main hull. So we'll select all that. Go quad remesh. And maybe we'll pick a few more elements for that just because it's physically bigger. We'll preview. It's thinking and making the mesh for us. It's generally looking okay, I think. And maybe let's just, this is looking, there's a bit of overlap here, so we'll go hide input objects. Yeah, that's pretty much fine. And so we'll go delete input objects because we don't want to keep the surface, we just want the mesh. I see the deck's not there. I don't think that's a big deal, but maybe it would be a little bit weird. So we'll use this as an example here, and we'll just change this to say 750 and get it to recompute and see if that top stays on there. Yeah. So I think that's just the way that the quad remesh algorithm is working in Rhino. If it has a little hiccup, it might have an issue, but you can sort of get it to regenerate it and try again just by using a little bit of a different mesh resolution there. So that's looking really good, and we'll go OK. And again, it's looking pretty good there. So now what we're going to do is we'll go save as. And we want to do the OBJ format here. So I'm going to go trimaran hull 30 meters, OBJ. And make sure we don't have that Rhino Z to OBJY. That throws things for a loop. And now let's go over to our ShipMo3D toolset, and I've sort of got a almost blank project here just from playing around before. So project data 30 meters, draft at midships 1 meter, height of CGs 2, but I mean honestly we're just playing around to get this into the workflow here. So I'll just make sure we've got the right file name here and run it. And maybe if you just look at the view output here, you can see the mass based on the displacement it's counting is about 100 tons here. That's great. So let's take a look at it. Plot panel hull. And that's looking pretty good. I like the ship parts view here because it clearly shows the wet hull area. And that's looking pretty good. So we're set to go on from here and perform some hydrodynamic calculations and seakeeping analysis. And for the meantime, this is what I wanted to cover, just like how you could go about doing this in a tool like Orca3D and Rhino and bring that hull form into ProteusDS. And that's it for now. So thanks for watching.